How are you all doing? I'm outside the shipping office here at Lime Street in Dublin City Centre, as you can see, and I just decided I'd do a quick vlog. I was here bringing a couple of clients to see this project a few days ago, and it became apparent it's a really good project with regard to doing a vlog, explaining about some of the new technologies, how the new technologies can be implemented into system design, and how they can be controlled with the new control methodology. So it's a lot of stuff that I promote in the designer training program. So just to bring it all to life for you, a lot of people see these on schematics or we talk about it or they see it in the designer training program, but we're going to show you around, show you the actual equipment, so hopefully it'll just bring it all to life. Okay, so we're on the rooftop here of Lime Street, and this is where we have our three multifunctional heat pumps. For anyone that's not familiar with the multifunctional heat pump, basically they provide cooling only, heating only, or simultaneous heating and cooling. Obviously, when you're in simultaneous heating and cooling, you're more than doubling the energy efficiency that you would have got typically from a chiller. Because you've pretty much the same input, but you have more than double the output because you're getting your heating for free. So we normally design these systems, a lot of people will be familiar with this from the designer training program that we give, where we explain that you want to design your heating system as low as possible, typically 45-40, and you'll find it's very much the industry norm nowadays. And then we use like the WWB, the water booster, which I'll show you in a minute in the basement, where we can boost the temperature up to as high as 80 if need to be, but you don't necessarily need to go that temperature. But we design our system as efficiently as possible, where we have our LTHW, typically 45-40, like I said, and the chill water, typically 6 and 12, 7 and 12. By the way, you can have a dynamic set point. You don't necessarily need to have the same temperature all year round. Obviously, as the ambient temperatures, a lot of people are used to weather compensation. You would have had on boilers. We can do the exact same with chillers or multifunctional heat pumps, or even heat pumps for that matter. So as the temperature comes up, we don't necessarily need your water temperature is high. You can drop that, and vice versa with the cooling. As the temperature drops, you can adjust it as per the load or as per the ambient. So you can see the installation here brings it all to life. A lot of people are used to seeing these on schematics and linear drawings, and we often do schematics where we have a blue beam, where we have the image incorporated, again try and bring the image to life, or the schematic to life, whereas you can actually physically see what they're like here now. So normally three of them are connected in parallel. You have two pipes for your heating, two pipes for your cooling. They're all married back to your common flow and return header. They will often go to buffer tanks, which you'll see now in the basement in a minute, acting as a decoupling tank. And then the next thing we can do is how we control them. So I'm going to bring you into the small plant room on the roof here and show you the multi-chiller sequence controller, or the multi-unit Evo is the latest version. So as you can see, we're in the basement plant room here. This is where we have our buffer tanks for Fiorini. These buffer tanks, by the way, are designed in a way that they're decoupling tanks. So we've two pipes in, two pipes out to separate a primary loop from a secondary loop. I've done an article, a specific article, by the way, on buffer tanks. So just go onto LinkedIn, look at my articles, and you'll see that there. We have our WWB, which is the water-to-water booster from Aermec, which is specifically designed to take the source from the NRP, the multifunctional heat pumps, and use it as a source and to boost the temperature to a high temperature, normally to satisfy your domestic hot water or any high temperature requirements that are needed. And of course we have the clarifiers also from Fiorini. These are a twin coil clarifier, where we have the first coil, which is fed from the LTHW, the lower temperature, which will get us to about 2/3 temperature, so typically from about 10 degrees supply to about 40 degrees. And then we have our secondary coil coming from the WWB, which will boost the temperature from typically about 40 to 60 odd. Obviously we need to go above 55, 60 for Legionnaires, and to satisfy the high temperature that's important. So that's everything that we have here. Of course, you have your expansion tanks, your pumps, and all the other things that are required typically in this type of hydronic system. Okay, we're in the control room on the rooftop here, just beside the multifunctional heat pumps that you saw outside there. What we have here is the multi-unit Evo. So it's basically the latest evolution of the multi-chiller sequence controller. I did another specific vlog with regard to the benefits of the multi-chiller sequence controller. Unlike the old-fashioned way where we had a BMS system, and the BMS would normally have 4 wires to every chiller from a control perspective, remote on off and a common alarm. And we now know running a chiller up to 100% load is not as efficient as running 2 chillers on a lower load, because the efficiency is far greater. So the multi-unit EVO is the component that monitors the temperature in your system, common flow, common return. There's a direct correlation between your delta T and your load in the system. So obviously as that load is increasing and as the units are ramping up in capacity, we know that they're getting less efficient when they get closer to the 100% load. So like I said, this unit monitors that. You can see it's not fully connected up just yet. So you have a Pico 5 Plus controller, and that is basically talking to each multi-function heat pump, the NRP. So it's enabling them, and it's also monitoring your temperature. We have an expansion board here with the temperature probes, like I said, connected to common flow, common return, and depending upon the delta T, the load, it manages the multifunction heat pumps to come on or off to optimize the efficiency in the whole system. So any system that has 2 or more chillers, heat pumps, or multifunction heat pumps, this really is a no-brainer. It pays for itself in no time at all. You will need the expansion board, by the way, if the probes tend to be a lot further away, or if this unit is very far away from your controller. It's very simply connected to a serial interface, an RS485, that communicates with each unit, and it's just simply connected in series. So it's a really good component, very much a game changer with regards to optimizing the efficiency of, like I said, 2 or more units on the same hydronic system.